Greetings everybody, my name is Philip Hegeland and I will be presenting the Traceability Driver submission for the FDA Traceability Challenge. This is not a traceability solution, rather this is a software add-on or tool for solution providers that will help them become interoperable. Today we have standards that help solution providers become interoperable. However, these standards either have too much flexibility or they are not interpreted consistently enough to enable true interoperability. We need traceability to be as easy as email. This is a tool that utilizes standards like EPCIS, GS1 Digital Link, and GDST and is not a standard itself. The main purpose of this tool is to reduce the development costs of interoperability for solution providers while also increasing the consistency in which the standards are implemented. This aims to increase interoperability across the traceability industry as a whole. The technical details on how this tool works cannot be covered in 5 minutes, but I will try my best with a few diagrams. Here you can see that each solution provider would install the tool to their existing traceability solution. Then they can use the traceability driver to talk to all other solution providers that installed the traceability driver. The traceability driver uses GS1 standards to talk to each other. Here you can see that we take a wheel and spoke approach to mapping data between solution providers. Each solution provider who implements the traceability driver writes a mapper between their data model and the common data model. Then using this wheel and spoke approach, we can move data between any solution provider while minimizing the complexity. Each solution provider is merely responsible for maintaining a mapping between their local data model and the common data model provided in the traceability driver. Now, enough diagrams. Let's see an example of this at work. Here you can see that we have two different traceability solution applications. We have the XML solution provider who uses an XML data model, and we have the JSON solution provider who uses a JSON data model. We have no data on the JSON side, and we have some events and trade items on the XML side, right? So we have events and master data. Here we're going to open this up and grab the EPC, and we're going to request the event data for this EPC. Here you're going to see an illustration of what's happening technically behind the scenes. It may take you several times of watching this video to fully grasp the technicalities of what's happening behind the scenes. But for the most part, JSON solution provider is going to request the event data from the XML solution provider using the traceability driver. After receiving the event data, then they will scan the event data that they've received for any master data that they're not aware of, right? So any G10s, GLNs, PGLNs, etc. Right? And then they're going to turn around and request that master data from the XML solution provider, right? So first they're going to request the event data, scan for master data, and request the master data. Again, I highly recommend reviewing this video 1 or 2 times if you really want to understand all the technical details of what's happening under the hood. And I would like to stress that this is all built on existing GS1 standards, that there are no new standards implemented with the traceability driver. He has now successfully received the data. So now we can see here we have those events, but it's in our JSON data model. We have the trade items, locations, and trading parties, and we've received that event data using the traceability driver. The last thing I would like to demonstrate is that all this code is on GitHub. It's public. It's under the MIT license, so it's free for anybody to use however they see fit. So I really appreciate you reviewing this submission. Thank you.